Hello friends, in this video we discuss about the basic properties of electric charge. The following are the important properties of electric charges: additivity of charges, conservation of electric charge, quantization of charges. And finally, we give an introduction to Coulomb's law. Let's start the session. Basic properties of electric charge. Charges are classified into two, that is, positive and negative. When a positive and a negative charge come together, there is a tendency to cancel each other. Here we discuss about the important properties of electric charge. The first one is additivity of charges. We know that charge has magnitude but no direction. It can be either positive or negative. The total charge of a system is obtained by simply adding algebraically like real numbers. If the positive charges are Q1, Q2, Q3, negative charges Q4, Q5, Q6, then the algebraic sum is Q1 plus Q2 plus Q3 minus Q4 minus Q5 minus Q6. This is the first property of electric charges. The next important property of electric charge is conservation of electric charge. According to this law, the total charge of an isolated system is always conserved. It is not possible to create or destroy net charge of an isolated system. Now, consider two bodies A and B. The two bodies are rubbed together so that the A acquires positive charge and B acquires negative charge. That is, the total charge of an isolated system remains constant. The last basic property of electric charges is quantization of charges. This was first suggested by Faraday and it was verified by Millikan in 1912. The fundamental unit of electric charge is Coulomb. By convention, the charge of an electron is taken as negative and that of proton as positive. The magnitude of the charge of electron or proton is 1.602 into 10 raised to minus 19 Coulomb. And this is the basic unit of charge. It is found that the electric charge of any system is always an integer multiple of a least amount of charge E, where E is the charge of electron or proton. Hence, the total charge of a body can be written as Q equal to plus or minus NE, where N equal to 0, 1, 2, 3, etc. And this is the quantization of charges. Now let us discuss the last topic, Coulomb's law. Coulomb's law states that the force of attraction or repulsion between 2 point charges is proportional to the product of charges and inversely proportional to the square of distance between them. Now let us briefly explain the Coulomb's law. Consider 2 point charges Q1 and Q2 separated by a distance r. Here we consider two situations. If Q1 and Q2 like charges, they repel, and the second figure is if Q1 and Q2 are positive and negative, then they attract. Okay. Then by Coulomb's law, F proportional to Q1 Q2 by R square, the force between two charges. Here the proportionality sign is replaced by constant K. Then F equal to Q1 Q2 by R square, where K is the proportionality constant. The proportionality constant is given by K equal to 1 by 4 pi epsilon, where epsilon is the permittivity of the medium. Okay. In SI unit, the value of K is 9 into 10 raised to 9. If the charges are kept in free space or air or vacuum, K equal to 1 by 4 pi epsilon 0. Here the epsilon 0 is the permittivity of free space and its value is given as epsilon 0 equal to 8.85 into 10 raised to minus 12 c square n raised to minus 1 meter inverse square. Therefore, 1 by 4 pi epsilon 0, by substituting all the values, that is 4 pi and epsilon 0, we get 9 into 10 raised to 9 nm square c inverse square. Hence, in air or vacuum, F equal to, we can write it as 1 by 4 pi epsilon 0 q1 q2 by r square equal to, we are putting the value of 1 by 4 pi epsilon 0 here, therefore 9 into 10 raised to 9 q1 q2 by r square. And finally, we got the mathematical expression for Coulomb's law.